that. All right. Yeah, everything looks ready. All right, so what we're going to do today, three things mainly. One is let's turn this off. We're going to look over here at this thing again. I never did actually replace the little capstan here. I had already replaced it, but I was going to replace it with the one that uses the little geared rollers. So we're going to do that, which will create a new thing that we need to do called modify the eSteps. So E talking about extruder, steps referring to how far the stepper motor turns, because the little drive wheel I'm going to replace. Oh, let's make that not do that. There we go. The little drive wheel I'm going to use to replace the existing one. So I'm going to have to take this brass off. Actually, I'm going to take the whole stepper motor off because that brass one is it's press fit on there. Or well, maybe it's heat shrunk on there actually, and I'm not going to be able to get it off without a lot of work. So I'm just going to replace the whole thing, the whole stepper motor, with a different one. Actually, we'll take that brass off of there. But I'm going to replace all of that, but the diameters are different. So this diameter is different from this diameter, and so what that'll do is the stepper motor is going to be told to move the same amount no matter what, because the machine doesn't know that I've changed that piece out. So the stepper motor is going to be moving, but since the diameter on the new one is smaller than the diameter on the old drive wheel here, then when it moves, it's not going to push as much filament through, so everything's going to look under extruded. So I'm going to have to modify the amount of steps per millimeter of filament that gets extruded out. And that's called changing your eSteps or something along the lines with eSteps. A lot of times you'll hear like you go to a troubleshooting forum or whatever, and you ask a question. They have the two answers. One of them is, have you leveled the bed? And the other was, check your eSteps. So those are kind of true, that those things can cause problems. So it can be that the bed itself, what they mean by level is what we did, I think, last time, where we it's more like tramming the bed instead of leveling the bed, because it's not like you get a level out like a spirit level and try to make it level with the earth. You're trying to make it parallel to all the motion of your printer. So that is important, that you have it parallel to wherever your print head is moving around at. You do need that. So that's true. And then the other thing they'll say is, well, check your eSteps. And that's also true. Although it seems like most of the default settings these days are pretty accurate. Now in this case, it won't work because we're clearly going to be changing the diameter between these two things. So we will need to change our eSteps. So first, let's get this. Oops, need that part. Hopefully, I don't know where it went. There it is. All right, so let's get this off of here. I've already taken the filament out. In fact, I could. We'll just leave that off. We'll take this guy off of here. Actually, let's take that one off first. There is a spring in here. So you'll notice all of these usually have some kind of spring right here that is adjusted with a screw. Typically this is going to be annoying. What that's doing is that spring is applying pressure to the filament here, through this handle. And if you're having unpredictable extrusion, like it's blobs sometimes and other times it's missing, it's got gaps in it, it could be that you just need to tighten this screw up. Just tighten this up to put more pressure on the filament, and maybe it's just slipping some. That unless you've changed something, that shouldn't really be the case, but it's worth trying. The other thing that can happen here is the pieces you get to start with on most printers for this that I'm taking off now are plastic, and it can fracture without actually coming all the way apart. It can just crack, and a lot of times that crack is on the bottom and you won't notice it. It'll look like it's still doing what it's supposed to be doing, but it's not. Let's see if I can get that off of there. So there'll be a crack, somewhere down in here a lot of times. and you won't be able to notice that unless you actually take this thing apart. So I'm going to save all these pieces. This is not a bad setup here. It's just not the one I'm going to put on here. I kind of want to do this one just to show you how it's done, but also so that we can go through changing eSteps. We're going to take that screw out because it's covering that one. Okay, let's get that. I think I'm going to have to reuse this hardware also, so we will keep all of it handy. And that one we're just going to have to take that guy out of there so that we can get to the screw. I don't think I can get in there. Nope. Hopefully these ones I'm taking off will match with the one I'm using here. I'm actually, oh wow, that's not going to fit. So there is one thing that we'll have to sort out here shortly. That I'll have to see. All right, so there's our old setup. You can just unplug these. Now, our new one is going to go right back in the same place. I've just got to take this off. So there's at least one. Sometimes, yeah, this one does have two. And if yours has this kind of set up with these set screws, you can just slide that thing off of there. The old, or the one, not old, but this one's actually older. This one, there's no set screws. That is just pressed on there, and it's, unless you have this tools to take it off, you're probably not going to easily get that thing off. Also, this one's longer. See, the shaft is longer on here, so what that'll let me do is put something like this so I can manually turn it if I want to, or if I need to. So let's mount it with this in the same orientation, like that, and then it's going to go under here. All of these should line up the same, you know, the whole pattern, as long as it's a NEMA 17. Like I said last time, the 17 actually talks about the spacing of those holes, how they mount together. It has nothing to do with the motor as far as how strong it is or anything like that. It's just, does it mount to that pattern? And these are all NEMA 17 motors. All right, let's start reassembling. So what my problem is going to be is actually this guy, this little coupler that screwed into here is one size. The new one is a different size. So I'm going to have to come up with that size coupler here. Let's look through my parts. Let's see, there's another small one. That won't help us. Check this set of parts. That one might, I can't tell if that's screwed in or if it's pressed in there. Let me get a pair of pliers. See if we can, it's always good to keep all your parts because you never know when you're going to need certain ones. So I found another one of these couplers. Yeah, that'll work. All right, so we'll do that. To get these things on and off, the idea is that you press that little ring in, and then it's supposed to slide out of there, but sometimes, oh, that one actually did. So that's the way they come out of there. And to reassemble, you just press them in. All right, let's get our stepper motor. Let's make sure our wires aren't all tangled up. Let's get this guy up here. Let's put our, this one, it has to go under the arm, so it needs to have a countersink screw head on it. Here's the two different. So the countersink has that triangular shape where the button head is flat on the bottom. So I need the countersink one in that hole. Let's see if I can find the hole. There we go. Now we need to do this kind of thing. And now we're at least put together there. See, we're going to have to put this one in because, again, there's going to be a screw that's going to be in the way once we put that in, that tensioning screw. I'm not tightening any of these up yet. I'm just getting them in place. We're also going to need to drop, oh, looks like we need to put that on before we put that. So let's undo that. I'd have to take it completely apart to put that on there. I'm going to drop that guy on there and start again. Okay, so that looks okay. Now we need a couple of things here. We need our longer screw that's going to go in this arm. We have to tighten that one up first, though. Right now I'm missing this screw. Oh, I think it never came out of the part. So let's get those three in. Oh, is that one not going to be long enough? Yeah, it is. Okay, let's tighten these three down. And you know, you don't have to be super tight with these. Now let's get this guy, the longer one. There is this little insert, kind of hinge, that's going to drop down in there. Let's see if that looks like the right one. Oh, it's a different size. Before we get this one too tight, though, actually maybe even before we get it tight at all, we need to put our spring in there. Let's see, I've lost here. All right, so here's the spring that was in the previous one. This is like the spring that is normally in there. I'm going to put this guy in there. It's a little bit stiffer spring. Not that we need that much pressure, but I have it here. I think this one actually came with this setup anyway, so we're doing something like that. I need the little inside part, though. Let's see. Where did it go? No. Well, this one we just want to adjust. Except that's not the right size. See if this one's the right size. I've got a bunch of screws over here from 3 or 4 different versions of these things. All right, now we also have to get this all lined up. So we need to get this guy up so that it'll mesh with that one. And some of this we just are going to have to do all at the same time. Let's tighten this down. And this one, you don't want to tighten this one too much or it won't pivot. You do want it tight, but that's also why that insert's in there. Some of the ones, the original ones that come on these printers don't have a sleeve inside there. And so if you tighten that one too tight, it tightens down the whole arm and it won't apply the pressure you need to the filament. And it looks like I'm not going to have enough of a shaft anyway to put this whole guy on there. Oh well. This one's hard to do because it's right up against the Z-axis. think we're actually making progress, but it's really slow. I'm not sure we are making progress though. Something seems weird there. I think this screw that I'm using is not quite long enough. So let's trade it out. It's gonna be a lot easier if we get this this screw out of here. Yeah, it wasn't long enough. It was just kind of barely scratching on the thing there. See about this one. All right, that one actually might take us a while to screw in there. And that fell back down. All right, so now we need to get this lined up with this so that they mesh together, and there's a little groove that the filament actually passes through. Some of these shafts, well, let's see, can you tell? I think you can tell. Some of these shafts have a flat edge. You can kind of see the flat edge right there, or flat side. That's so that that set screw, you know, one of those set screws like that one, can sit against a flat surface instead of sitting on the round curved surface. So this should have one at least set screw, yeah. And I want that set screw on the side with the flat. Alright, so I've got to get everything lined up and tighten that. Okay. All right, I think we got that. Let's put our little spring back in there. This is not actually doing anything other than keeping it kind of from shooting out of the side. Let's make sure that's tight. Okay. Let's just insert, oops, now we're zoomed in too close. Insert our Bowden tube into here. That should do that. Now we have dual sides here. Let's go ahead and load our filament. I'm using some PETG. We're going to print with that for a little bit. So sometimes it can be difficult getting the filament to feed through here. So if you cut a really steep angle, you know, real steep angle, a point on the end of your filament, it'll feed through easier. Sometimes. Yeah, there it goes. Okay. There we go. All right, so let's heat up our nozzle here. Just so you know, a lot of times, oh, it's already heated. All right, good. It's at 200. It's at 200. I've got PETG in here. PETG will maybe extrude at 200, but let's go up a little higher than that because it normally is higher than 200. I'm going to go to 220. 225 apparently, because that's what it scrolled to. Just because PETG is a material that's going to melt, or well, not melt. Melt is the wrong word for this stuff. It's going to flow better at a little bit higher temperature than PLA. All right. So now what we need to do is, I'm actually going to undo a little bit of what I just did. I'm actually going to unscrew this, since I have a Bowden setup. So this Bowden tube kind of constrains the filament and gets it from the feeder down to the hot end. But I need to adjust these steps, steps per millimeter on this extruder. So I'm actually going to unplug this. I'm going to pull the filament back out, or at least most of the way back out. And let's see. First, let's check and make sure I've got enough tension on this spring. I can't really change it the way I've got it set up, but oh yeah, I can't pull this without turning the gear, which is what I want. I don't want to be able to move this filament freely through here while it's clamped on it, because then it's definitely going to slip. So what I'm going to do is going to chop this off. I'm going to shear it off right there. So now there's zero filament coming out that end. And I'm going to go over to my control panel and just tell move axis extruder 100 millimeters. So I'm going to extrude 100 millimeters of stuff. So motion, move axis. You do have to have your printer heated up, at least the nozzle. The bed doesn't matter. But most of the printers have a fail-safe where if the nozzle is not heated to, I don't know, 185 or something at least, then it won't extrude filament. So motion, move axis, extruder, 10 millimeters at a time, and let's spit out 100 millimeters. Okay. So you can kind of see some coming out there. So what should happen is the way I had it before with the bigger drive gear, right here, it would spit out 100 millimeters. But now that I've got a smaller gear, I'm calling them gears, but these drive wheels, these are geared drive wheels. They do actually have gears on the bottom. That's both sides are now turning instead of what I had before where this side just spins freely. Now both are turning and pushing the filament through. So it gives you a little better grip and more control over the filament coming out. So I'm expecting to have less than 100 millimeters come out. You can do this with your stock setup, just to check to make sure that it's configured correctly. Maybe there's some reason it's not quite doing what it's supposed to be doing. So it's stopped. You want to cut it off again. And get my calipers. Always make sure to zero them so that when they're closed, they're reading 0. I'm going to measure this thing. I'll have to do it off to the side, I think. Let's see what I got. So measuring, I've got 68.06. 68.06. So let's write that down. 68.06. I wanted 100 millimeters, so I was short by calculator. Let's see, 100 minus 68.06. I was short by 32 millimeters, 31.94 millimeters. So what I need to know is how many steps, eSteps. So eSteps are the number of extruder steps. In this case, steps are little turns of the extruder. When it's making one little turn there. By the way, these have 200 turns per revolution. So how many of those does it take to extrude a millimeter of filament? And so I need to know what it was already set at. There's a couple of ways. You can actually do that through the control panel on your printer, and that's completely fine. But I'm also going to show you that you can connect to your printer with a USB cable. So I've got a USB cable connected over to my computer, and I've got this piece of software. This is free. It's called Pronterface, so Pronterface. You should be able to find it. Now it's an older piece of software, so let's see what the 2015 was the last time it looks like it was updated. So it's older, but it does what we need to do. You can do this kind of thing in Cura and in Prusa Slicer. They will also do this. But what you do is you get a piece of software like this, where you can actually write gCode on your computer and send it over to your printer. This is one way to modify your eSteps and do a lot of other things. You can actually do all of this without this at all. You can just use the control panel on your printer. We'll look at that in a second, but there might be other reasons you want to connect and control your printer through USB or monitor it through USB. So there might be some reasons you want to do that. So there's two pieces to make this work, though. One is your USB cable is an actual data cable and not a charging cable. So let's see if I have. I think I usually have a little cable. Yes, this one. So this cable. Now this is a really short one, but this cable is just charge. Like, it's broken right here. There's only two wires, a red one and a blue one. That's power and ground. So some USB cables, they'll have the exact same, looking ends on them, but all they do is charge. So if you get one of those and plug it in, your printer will actually come on, because it'll be receiving power from the USB cable from your computer. So it'll turn the screen on, and it might do a little bit of stuff. It won't print. That way there's not enough power to actually heat up the extruder and print. But it might come on and look like it's working. But you go over to your software here, well, here, and you try to connect to your printer, and it won't connect. So there's some problem, it won't connect. So that's one issue, is you have a USB cable that's only charge, it doesn't have data. The other thing is that if you have Cura or a slicer open and you plug into USB, then that slicer software, particularly Cura, is going to assume that it's the thing that needs to be in charge, and it's going to take over that COM port, and you're not going to be able to use something else like Pronterface to connect to your printer, because it's already connected to Cura. So if you have a slicer open, or if you have a data cable instead of a charge cable, then this software like Pronterface is not going to be able to talk to the printer, because either there's no wires to actually talk on, or they're already occupied by Cura. So let's see what we've got here. Let me unplug and reset this. And let's try to, I'm not sure what. Maybe it's 8. No. Or maybe I've got, let's turn the printer off. And I might have to restart Pronterface to get it to recognize. We'll give it a shot here and see. Well, all right, I'm going to restart this. There it is. It's not even a thing you install for this one. It's just a executable you download. All right, let's see. So you get COM ports. All right, so COM 9 is the new one. That must be the printer. And you have a baud rate. Usually the 115,200 baud is the correct rate for connecting to these things. So we hit connect, and printer is now online. So all I had to do was restart Pronterface, probably because I had already had it open and then it disconnected and wouldn't reconnect. So sometimes turn it off and back on really does fix it. All right, so what I needed to know were what are the current values of eSteps in my printer. I can get that from the control panel on the printer. We'll do that in a minute. So M503, oh, I'm down here at the bottom of the very bottom of the screen, and I can type gCode in here, and M503. So this command will output a whole bunch of stuff that's in the printer's memory. So that's all the stuff right there that outputs. And all these echoes are the printer is sending this information back to my computer screen. And in here, there should be an M92 right here, this line. So these are all the current steps per millimeter. And I've got one for the x-axis, which is 80. One for the y-axis, which is also 80. One for the z-axis, which is 400. So those numbers mean it takes 80 steps of the x extruder to move a millimeter in the x direction. So I've got all of those. And then I've got E. So my current extruder steps are 96. So that's useful. So if I have 96 steps per millimeter and I only got 68 millimeters, that was from just measuring a minute ago. So let's take my old steps per millimeter, 96, multiply, I asked for 100, so 96 steps per millimeter times 100 millimeters is 9600 steps, but I only got 68.06 millimeters. So let's multiply this guy times 68.06, 0.06, and let's see. I gotta think about my math now for a second. Actually, you know what? There are eStep calculators. Let's just do that. Let's see. I think I've used this one before. 96, my current one. The actual length that was extruded was 68.06. That's what we measured. This is, oh, well, we do have to make sure that this is assuming the same amount that we did. We did 100 millimeters, so that's right. Our new eSteps 141, so it's just a percentage. They even give me the command to set it. So M92 E141.05. Sometimes you can't use that many decimals. I'm going to do 140. I'm going to do 141 because I'm not sure that I can do the 0.05 or not. So let's go over to Pronterface and do our M92 E141. Okay. So it sent that command. Now if we do a M503 again, it'll repeat the new values to us. There's our, now it does have 2 decimals there, so maybe we can, let's try doing all of them. Sometimes you can, sometimes you can't. So it was 05. So let's just try M92 E141.05. And then let's just check to make sure it popped it in there. There it is. Now let's save it with M500. So M500 saves all of the stuff that's in the printer's memory as far as configuration. And then it stored it. Let's just check again. M503. It's there. Now let's turn our printer off. Let's disconnect from the printer. Turn the printer off so it doesn't have any power. Unplug it from USB so that it has no power at all. And then let's reconnect and make sure that that 141 got stored in there. We need to test it also to make sure it actually is giving us our 100 millimeters. So let's reconnect. Actually, let's see what. And let's do M503. It did store it after power down, so that's good. But let's actually test it to see that our changes actually worked. So I'm going to turn the nozzle on to 220 or somewhere around there. Ooh, not 260. So, like I said, we do have PETG in here. So, if I look at this is Overture PETG, and it says nozzle temperature 230 to 250, and a bed temperature 80 to 90. So those numbers are pretty typical for PETG. So it does print hotter, but the hotter you go, you get to the point where this tube right here, this guy that's holding the filament, it goes down into the hot end, and it is made of a Teflon material, and Teflon begins to break down in that range, 240, 245, somewhere in that, somewhere in that range that PETG prints at. So you typically have to print at the lowest temperature possible for PETG. PETG is a good filament for your next filament. So you start with PLA. PLA prints really easily. It prints nicely. It's lower temperature, 200 degrees Celsius or so, and it's plenty good enough. There's nothing wrong with PLA until you want to start using it as a part material. So if it's going to experience any kind of heat, or there are material chemicals that can kind of affect it. Usually it's heat is the issue, or maybe it's just not strong enough. So the next material up, without changing a bunch of stuff, getting enclosures and ventilation and all that kind of stuff, is usually you're going to go to PETG. So that's why we're printing with PETG, because, well, you need to know a little bit about glass transition temperature. Let's talk about that for a second. So here we've got a little curve. Actually, we don't have a curve yet. We've got a set of axes. So let's put, let's make it this way. Let's put temperature down here. And so glass transition is it's a range. It's not a individual point. So it's a range of temperatures where your material goes from kind of like a glassy state. Think of the y-axis as how glassy or how rigid your material is. So up here this is glassy. Not necessarily glassy like brittle, but it's it's a solid crystalline type thing. And then it gets to some point and it starts dropping off. And so this range, somewhere in the middle of that, is your TG. So that's the glass transition temperature. And then you get into this zone here, maybe like that, where it's kind of rubbery. So it's more flexible, but it doesn't really flow right. You might be able to print at this temperature, but it's not going to come out very well. And then it goes off into something like this, where it gets into rubbery flow and viscous flow, but it's flowing. And the hotter and hotter you get, the more it gets into like a viscous flow. So this range, this glass transition temperature, is usually given as a number, but it's really a range. And you can see, this is kind of a representative graph of what it would look like in a material. So PLA's glass transition temperature is somewhere around 60 degrees Celsius, so relatively low, where you print something out. I've got this part printed right here. I print this little thing and I leave it in my car. It's the summer here. The car temperatures are going to get, the interior car temperatures are going to get above 60 degrees Celsius pretty easily, if I leave it on the dash or something like that. And I'll come back and my part is all warped. It's not going to turn into a puddle, but it's going to warp and not be the shape that I wanted it to be. PETG has a little bit higher, maybe like 80 degrees Celsius or something like that. Again, it's a range, but it's going to be able to withstand more temperature, heat, before it starts to deflect and deform. So it's a good material. PETG is a good material for being, an environment where you actually need it to not deform under some kind of heat load. It's also a little bit stronger than PLA. So the general kind of three big materials then there's a bunch more. But the three big ones that you can probably get away with printing on your Ender are PLA at the easiest to print range, but it's not as strong and it has these heat problems. PETG is stronger and it has a better heat deflection. Its glass transition temperature is higher. And then ABS is stronger and much more heat resistant, but it's going to be much harder to print as far as now you got to deal with fumes and enclosures and all that kind of stuff. So, and there are some others in there. There's some nylons and things like that. There's one called ASA. So there's some other materials, and there are a lot of blends of materials. PLA Pro, PLA Plus, Tough PLA. There's all these kind of different blends where they're mixing polymers together. I would recommend if you've been doing PLA and it's just not holding up, it's not strong enough, or whatever, or you have a little bit higher temperature need, then try PETG next. It's the next easiest one to print. Our nozzle's heated up over here. Let's try to extrude a 100 millimeters of filament. We can actually do that in Pronterface. We could go down here. Remember, you've got G1. We can send it an E100, and that will, and a feed rate. Let's do slow, F200. And let's see what we get here. So there we get some feeding out. You could also move the extruder with your control panel. I've got the Bowden tube off, so there's no back pressure on here. So this is just is the feeder feeding the right amount of filament. Now, it doesn't necessarily mean that I'm getting the right amount of filament out of the nozzle. There's going to be another calculation later on that we can look at to try and tune that. But first, I want to make sure it's mechanically doing what it's supposed to do. So there's definitely more here this time, so that's good. Let's measure this little piece and see if it's at 100 or not. Sometimes you have to do a couple of these. That's really close. I'm going to leave it like that. I don't think I could get it much closer reliably. I should probably do a couple of these and test them to see what the average is, but this one's really close to 100 millimeters, so I'm going to leave it there. Like I said, sometimes you have to do it more than once. So let's put this guy back on. We'll have to do this. Oh, this is, so if you can't get your filament to feed, you can take this guy off. Just unscrew it. Don't take it off here, but unscrew it, and then you can feed it on there. If you're just having trouble with making it sharp and feeding it in there manually. All right. Now let's feed this guy all the way in. A little tangled up over there. Let's look at the control panel, so that in the event you don't want to go in there and mess with the gCode. Let's look at it over here. Where are you at? There you are. Can we get it to be not so glary? Maybe, maybe not. It's a big glare right on it. I think you can read it though. So in this configuration, you've got, I think it's in advanced settings. So they might be in different menus, but there's steps per millimeter. And there's your eSteps. You can click on it and change them. It did round it to 41.1. And I did over extrude a tiny bit. So probably if I dropped that down to 141, it would, and we can just do that. Well, it went off. We can do that pretty easily. So advanced settings, steps per millimeter. And then we can go down here. Well, where's it going to be? Oh, store settings. So you need to store settings on your control panel is the M500 command. Usually it beeps to tell you that it's actually stored them. It didn't do that, so I'm not sure why. But this is not running the exact stock firmware, so that might be why it's not beeping. All right, so we've got that. Let's look at what it... I'm going to unplug the USB here. So I think we're done with prawn face for the time being. Let's look at the Cura settings for getting this thing to actually print PETG. There aren't many things you need to change though. There's a default set of material settings in Cura, and most of the time that's all you need to change, is just change that I'm using this other material now. While it's loading up, I'm going to try and get some of our stuff kind of out of the way. Got lots of little pieces now from that feeder, and I want to save them. Okay, looked like Cura came on. So in Cura, you just drop in your part. Oh, well, I guess you don't even have to have a part. I was printing these things. Oh, I'll show you this. Let's get, came in way over there though. It's under the bed. Get on top. There we go. If you're in the prepare menu, oh wait, hold on. There we go. If you're in the prepare menu over here, this middle block is materials. And so there are some that are particular, like you've got a name brand, eSun or whatever. Usually I don't have one of these particular brands, so I go to generic. And then there's your generic materials, and I just click on PETG. And this little thing will say, hey, you've got these settings set up. Do you want to keep those or discard them? Normally, I'm going to discard them and let it put all of the new settings in. That was an infill percentage because I wanted a part to be heavy. And what it'll do is it'll go in and give you your default stuff here, but then it'll change your print temperature. So it's saying print this at 240. Again, that's at the very upper limit of when this Bowden tube is going to break down. Build plate at 70. That's at the kind of lower limit for the build plate temperatures for PETG, but it did work. I printed, remember we changed out the bed to this textured PEI bed, and it worked fine. PETG on straight glass, so maybe you're printing straight on glass, that's usually a bad thing. PETG on glass, you need, where'd it go? Well, you need some release agent like this. You know, you need something like this if you're printing straight on glass, because PETG will bond to the glass in a way that you'll probably break the glass getting it off of there. So if you're printing on just a sheet of glass, which is totally reasonable, you go get a little sheet of glass out of a picture frame even and use that for your bed surface. It gives you a shiny surface on the bottom, and it sticks really well when it's clean, but it'll stick too well to PETG. The PEI, it works fine. It'll release when it cools down. It slowed it down a little bit. Could probably, PETG is a little bit stringier. You don't want to cool it as much. In fact, look, their fan speed's only at half. So normally this is at 100% with PLA. With PETG, it's a little, you can print with no cooling at all, and it'll just be a little stringy. Surface finish won't be quite as good, but it'll be a really strong part. If you print with 100% fan speed, it'll print, but it's going to delaminate pretty easily. So normally you're printing PETG about 50% fan. And that's all it changed. So everything else, all I did was load up the filament and hit print. I kept all the other, well, I did change the number of layers and the infill. The infill was like at 50% because I wanted that part to be heavy. and there's no other special thing to it. I will say that you sometimes have to raise your nozzle a tiny bit, so that you're not squishing that PETG quite as much on the first layer, but I didn't have to do that this time. Let's see, what else? Where are we at on time? We got plenty of time. Oh, I'll give you an example of, here's the thing I printed in PETG. Let's see, let's get some room. This guy. Well, it's off the screen. So, little electric violin. All of the green, obviously this is not, these are actual parts, but all the green is PETG, and it's been, I think, maybe 2 years now, a year at least, and it's been strung the whole time, so there's not any like deflection. It's not warped or anything. It hasn't been in a particularly hot environment or anywhere, but still, it hasn't really shown any effect of like a creep type of situation with having the string tension on the neck of or in the body of the violin. It hasn't really shown any tendency to creep. Now this one does have a carbon fiber rod running through here, so that's taken a lot of that tension away from compression and tension, bending away from the neck, and it's putting it into that rod that's running through there. But another good thing about PETG, I don't think I did it on this one. Let me see. No, I didn't. Another good thing about PETG compared to PLA in particular is PLA is really hard to smooth. So to sand it or anything like that, it just doesn't sand very well at all. You can kind of get it sanded. Usually you're filling it, so you put some kind of thick primer or some kind of filler to smooth out PLA. PETG, you can actually polish it. So you can get increasingly fine grit sandpaper and sand the PETG, and it will actually polish it to where it looks like a solid block of plastic, instead of, you won't see the layer lines in it at all. I did not do that on here. I do have another thing. I don't know where it's at though. Maybe I can find it for next time to show you kind of what you can get when you sand and polish. Like you can use even a plastic polish PETG, and it will look like a solid piece. You won't be able to tell that it was printed at all. That also helps with strength. You know, it's kind of making sure all the layers, there's not a crack somewhere that is going to make it fail later on. So that's another good feature of PETG. It's not any more expensive, really. Let's look and see. Do I have this one? Let's look at some PETG. Now, actually, this is the one that I have. It's on sale right now a little bit. So $23, that's about how much you're going to pay for PLA. It might be a little bit more than PLA, but not that much. And this Overture stuff, I've liked it a lot. It has a little bit, I don't have any parts handy. Here's one. Oh, you can also see what that bed texture does. So here's a PETG part, and there's that texture like it was printed on the textured PEI sheet. So that's kind of what you get, a little bit of a sparkly texture on whatever surface is against the print surface. But this is a really strong part. This is the part I printed 50% or 60% infill, I think, and it's quite strong and hefty. So, and it was out of this Overture stuff. Actually, it's probably showing me a bunch of Overture because I've bought that before. You can also get a carbon fiber filled Hatchbox is another good one. Actually, I haven't seen the Inland before, but these three are all good ones. Let's see if I can find a carbon fiber filled one. Here's one. So this does cost more, but what this is, you can get some carbon fiber PLA also, but I've used this brand in TPU before and it was good. I haven't used it in carbon fiber PETG. But now you're looking at twice the cost. Also be careful. Don't just look at the cost, not the rating, but the cost, but also look at the size of the spool. So most of the time you're buying 1 kilogram spools, but I'm sure you can find some in here that are 50, yeah, right there, 500 grams. So it looks like it's, oh, that one's way cheaper, but it's only half the amount. So be careful with looking at just the price. Make sure you're looking at how much of it you're getting also. So there's that does happen a lot, because some of these more expensive filaments, you don't need that much of it, but they might look cheaper, but they're actually not. So what this is, though, is it's PETG, and it has carbon fiber chopped in it. So it's not like strands of carbon fiber or anything like that. It's not going to be the same strength as a piece of carbon fiber, but it does two things. It does strengthen it, so you've got little chopped up carbon fiber pieces in the filament itself. What it does a little bit more, though, is that carbon fiber strand, well, not strands, chopped fibers, they will help it not warp as bad. So if you're having a part that is difficult to print because of warping, so as you're printing it wants to peel up or layers want to come apart or whatever, this usually happens on things that have thin walls, thin vertical walls, like a box, or a really large surface area that's kind of flat. Those corners will want to peel up sometimes. The chopped carbon fiber stuff will help it not warp as bad. So that's another reason. It does increase the strength. I'm not sure exactly how much, but it does increase the strength. But a big benefit is that it reduces the amount of warping in the part as you're printing it. Might have to get some of this and you know, try it out and see. One downside is most of the time whenever you have an additive, even if it's something that you think is kind of soft like chopped up carbon fibers, any kind of additive in the filament that is a granular type thing, so chopped carbon fibers or glow in the dark filament, or certainly the metals that get embedded, that you can get filament that you can print that has metal embedded in it, wood, any of those additives will typically eat up your nozzle pretty quickly. So the more you know, metallic the additives are, the faster it's going to happen. But even just glow in the dark filament will eat away your brass nozzle. So you can get hardened steel nozzle. And what this does, well, no, that one I would not get. That's a very particular one. Get something like this. So here is a pack of 5 hardened steel nozzles. So the hardened steel means that it's not going to wear as fast as the brass. It does change the heating characteristics, because now you've got your heater block is aluminum, and it was that the nozzle was brass, and so you had really good heat conduction between those two. And now you're going for your block is aluminum and your nozzle is steel, so that's not as good heat conduction between those two. So it will change your heating profile a little bit. We'll actually talk about how to tune that. We should have done that while we had Prana Face open, but you can actually tune the heating profile, the control system behind it, to better control the temperature of the hot end of your printer. But get you some of these, $10. You can get different sizes, but it looks like most of these are 0.4, but you can certainly get smaller and larger diameter nozzles. And these won't wear as fast if you're printing a material that has some kind of additive in the filament itself. They'll last much longer. The only thing you have to make sure is that they have the right thread. So MK8 is gonna fit most of the printers out there, but there are some printers that have a different thread profile here on the nozzle where it threads into the block. We'll actually change the nozzle here shortly. Probably not today, I don't think. Just to show you, there's a little bit of stuff you have to be aware of when you change it. But maybe we'll put a larger nozzle in so we can print faster. But you can also get replacement brass nozzles if you're not interested in printing the abrasive materials, because even your brass nozzle will wear eventually. It's going to take a long time if you're just printing PLA. Probably the whole class you would be fine without ever needing to replace your nozzle. But if you are printing material that is abrasive in any way, has some kind of additive in the filament, then you're probably going to want to replace the brass nozzle within, I don't know, a week of that printing. All right. There are all kinds of fancy nozzle things. Until you know what you want, I would just get these little $9 pack and it'd be fine for now. Oh, here's here is the next thing I'm going to print for the printer. So if you'll notice, the print, let's get this out of the way. The Ender printer, Ender 3 anyway, has, a lot of them have this open fan duct right on top. Now some of them have moved it to the bottom if you have a Pro or maybe a version 2. But a lot of them have a fan duct right there on top. And all kinds of things can fall down in there and get into your electronics. Your control board is inside there. So I'm going to print this guy right here. And it will sit, let's see if they show kind of installed. There's one. So it's going to sit right on there and let air still come in to the control box, but it's going to not let stuff just fall in there. You do have to be careful, and I'll have to check. I think I've got enough clearance. That knob, that bed adjustment knob right there, if you get one of these that's too tall, then they can collide and that can be a problem. So I think I've got enough clearance for this one. That's pretty low profile. You can also print, let's see, this one probably doesn't have it, but is there a picture? No. Well, you can kind of see these little rails on the side, the 80-20, or well, those are, I don't know, 50-50, or well, I don't know, whatever dimensions those are. 30 by 30 or 40 by 40, whatever the little rails are. They have these grooves in them. You can actually print inserts so that stuff doesn't get down in those grooves, because little filament pieces can get in there, trash can get in there, nuts and bolts can get in there, and it's hard to get them out. So you can print little covers for those grooves in your extruded aluminum rail. So I'm going to print this next. I don't think I want to print it in carbon fiber, although that's what I have loaded. I don't know. Maybe we will. Let's see. We'll get the level indicator one, and we'll take that over to Cura. Get that guy out of the way. So the level indicator. Oh, it's just which way to turn the knob to go up and down. That seems fine. We want to make sure support is not on. We don't need that much infill. Let's drop that back down to just 20. It won't have much infill at all anyway. Let's do 3 top layers. We don't need that many top layers. Let's do 2 bottom layers just to speed it up. That printing temperature seemed to work well with the previous part I printed. Fan speed was fine. Skirt is fine. Let's actually print it a little bit thicker. Let's do 0.28. To not have as many layers. We don't need 4 walls either. Let's drop down to just let's just do 2 walls. I think that'll be fine. And let's slice. Let's see. I can deal with the hour and 17 minutes. You want to preview every time just to make sure that you didn't accidentally turn on support and you got the whole thing clogged up in the middle or whatever. That looks good. There's a little bit of infill there. That looks good. So we will save that guy and we'll print it. Except I've lost my adapter for the little card. There it is. Okay. So we'll see how this comes out tomorrow, Wednesday, I guess. And remember, this is our first print since we've changed our feeder. So we do have to make sure that we don't have some weird thing going on with that. Let's see if we can kind of get an overhead view of this guy. So print from SD. There it is. Print. All right. Let's see. I don't know that I've had many questions that I need to answer. Don't see any in the chat. So I think we're good. If you think of some questions you need answers to, let me know, maybe in Discord or just email, and we'll look and try to answer some particular things. We're just gradually moving along different topics related to 3D printing, mostly filament based. We are going to do some resin based printing here in a little bit. It's just way messier, and it's nice. It's very high detail, but it's very messy. So we'll look at that. It might be something that some of you are interested in. We're also going to look at some modeling, like different software for creating particular models that take advantage of the 3D printing process, where as opposed to a subtractive process where you have to cut away all the material, you can grow and create whatever shape you want when you're doing an additive. And so that opens up some new design possibilities. We're going to look at that shortly too. All right, I think I'm just going to let this thing print, and assuming that our eSteps look like they're working right, we don't have any problems, then I'll let it print and we'll look at it on Wednesday. All right, I'll see y'all Wednesday. Let me know if you have any questions.